Hello, everyone. So this is João Reis. I'm the producer for the session. I would like to introduce you all to our speaker, Nicolas Rouyer, who will be leading the session, See What the Graph Sees, Demystifying PageRank through Visual Storytelling. Nicolas, the floor is yours. Over to you.
Thank you, João. I'm going to share my screen. Hope you can all see the slideshow for the moment. And I'm going to start now. So the title of this session is about demystifying PageRank through visual storytelling. So I'm going to introduce myself. I'm Nicolas Rouyer. I'm the Solutions Engineering Manager for Neo4j in Europe South. I hope to be friendly. We assume positive intent. So, but you can be sure I'm pretty friendly. And today I'm trying to get a little bit behind the idea of the Graph Data Science library, which is super helpful, super powerful. It comes off the shelf with Neo4j. But what's inside it? And what if we could visualize what happens inside the graph algorithms at each step of them? Really understanding not only the results of the algorithm, but how they went step by step. And so we're going to use a combination of visualization with NeoDash and Bloom, and also of a kind of state machine, if you're familiar with the term. Each step of the algorithm is the state of a state machine. And we're going to say to the machine, hey, +1, please, and get me to the next stage. We're going to use NeoDash forms for that also. A bit of context for PageRank. So PageRank is an algorithm that measures influence. It measures the transitive influence and connectivity of nodes together. And we want to find the most influential nodes in a graph. So we have, as a result of PageRank, an average or weighted average of the scores of its direct neighbors. PageRank can be also weighted algorithms. But to keep it simple, any node can benefit from the influence of connected influent nodes. What will be our data set here? It's a bike trips data set provided by Gabriel Ramos, and it's available on Kaggle. I have collected every resource on a GitHub that you will be able to scan at the end of the talk. So what will be my graph model here? Very simple. There is a bike trip. My bike trip has some start and stop time, start station ID, end station ID, and so on. In a given trip, I use a bike with a bike ID, and a trip starts from a station, goes to another station. Very simple. So we're gonna run a few Cypher queries, explore Bloom, and make some nice interactions with NeoDash. So at the end, I will get back to this page to show you the repo and how it's organized so that you can replay everything. First of all, let's look at our Aura instance. And we can start by showing the schema here. And you can see this is exactly mirroring the graph model, except that you have a link between two stations. I mean by that, if I have a trip from one station to another, then I could say that those two stations are linked together. We could try to see to understand what are the most frequent trips, because for each couple of stations, we can see that there are some bike trips. And for example, from the first two between East 7th Street and Cooper Square, there were, within a month, 590 bike trips. And so what are we going to do? If we were to do classical graph data science, we would first create a graph projection of the source, a station, source station, a target, another station, and we would project as a graph, and we would keep the relationship properties, the number of trips in the relationship. So we could do that, and then we would obtain a graph projection. Then we could perform either unweighted or weighted PageRank with a GDS library with a max iteration to 20, the damping factor, and the right property. So like this, I'm writing on every station node a PageRank property. And as well, I can do the same with a weighted PageRank property if I use the relationship property. Then I can look at the maximum PageRank. And the maximum PageRank station has a PageRank of 1.83. So this is the most central, most influential bike station in my data set. I can select this central station. This is the station ID 402. So I will put it as a parameter. And then I can look at the path outgoing from this station at level 3. And I selected only the links which have more than 100 trips. I can also look at some particular stations, the stations with no outgoing links. So I have 8 of them, and I have to take them into account. And also I have to check if there are stations with no incoming links, so you cannot go by bike to that station. Right. And so that was a little bit immediate. But what if I were to do the PageRank one step after the other? So we're going to look at that. And if we were to do it step by step, I'm going to show that directly in NeoDash. So here we have a NeoDash presentation with the presentation of the concept, the PageRank algorithm, and I'm going to go iterative here. And let's say that we have all the stations centered around my station 402, which is here. And I have I'm going to initialize my PageRank. And you can see here my diagram, all nodes are equal. They have the same size. And it means that the rank, the rank property I have, 0.00129, it is the same for everyone. Okay, so this is my starting point. And in fact, in my NeoDash, I have created my rank to be 1 divided by the number of stations. Okay. Then I'm going to iterate. And I can say I want only one iteration of PageRank with a damping factor of 0.85, which is the default one anyway. And so I'm going to go for one iteration here. Okay. And I'm going to refresh. And I can see that it has slightly moved. Okay. Now my rank is 0.002 here, and so on. And I could also iterate more if I want to perform 19 other iterations with the same damping factor. It will iterate over the different steps of the algorithm. And when I refresh, I'll get an updated view of the PageRank algorithm. In order to make it more visible, I have created an exponential PageRank that gives more difference between PageRanks, so that there is a little bit more contrast between the nodes. And so the think about it, inside my form here, I have a rather big Cypher query. I'm going to show that in here. I create for every iteration. I want to first find the stations that have no outgoing links. Then it's my dangling mass, okay. And then for each station, I will assign the sum of the incoming links rank divided by the number of links outgoing from this station. So that I get a little bit of the influence of the station that are linked to my current station B. And so I do that at every step, and then I get my my final network that I can also look at with Bloom. So, for example, I would ask, what is my max PageRank station? So it is 402, my famous station. You can see that here there is the history of the whole rank algorithm here. And then I can ask to develop the network around and show the neighbor stations of degree 3. And I can see that those stations is here my station 402, highest PageRank, okay. And there is a specific rule-based styling, so that we apply a size that is proportional to my PageRank property. I think that's pretty much it, what I could show you as well. Yeah, I can read the history of each station rank over time. And so, for example, for my central station, I started with the average PageRank, the one divided by the number of stations, and then the different iterations finally came to 0.0025 at the 20th iterations. And to so I can restart from the beginning, reinitialize my graph with equal PageRank, and then start again from the start and say, oh, I would like to iterate, for example, 30 times, another damping factor, submit, and I would obtain a different result iterating over that graph. And I think that's it. Maybe there are some questions. On time, hope. Joao, do you know if there are some questions? Okay, I don't think there are lots of questions, so I'm going to go backstage, and if there are any questions, you can contact me via LinkedIn, and please, yeah, go to that GitHub repo. I prepared everything so that you can replay the data import using the model in Aura, the dashboards, the Cypher queries, Bloom, and so on.